Hello children, good day to all. It's Yusuf sir here with a new video on one of the most important topic of physics, that is electricity. So let us begin this chapter. Before beginning of chapter, I'd like to ask a question to you children. So can you imagine a world without electricity? So can you imagine a home without fans, without TV, without refrigerator, without any electrical appliances like what you are holding a device in your hands? Will it work without electricity? Obviously your answer might be no, right? So we need to understand what is this electricity first. How does it work? What happens inside it? Okay, in this chapter we are going to learn about it. So to learn what is the electricity first, we need to understand what does this consist of. Electricity consists of electrical current. What is this electrical current? So electrical current is nothing but the flow of electrical charges. So current, the word meaning itself, it is anything which flows over there. For example, if water is flowing, we call it as a water current. If wind is flowing, we call it as a wind current. Similarly, if electrons are flowing, we call them as electric current. Now, before going to the electric current, let us study what are these electrons? Where does these electrons come from? So we are going to study about it. So electrons come from an atom. What is this atom? So atom, it is a basic fundamental unit. Okay, in this chapter we are going to study about electrical circuits, Ohm's law, resistance, electric energy and power and electrical components, right? So to study about this, all those things, we need a basic thing. What is that? Electrical charges we need to understand. So the question is, we are going to study what is electricity. To study that one, we need to understand what is atom first. So what is an atom consist of? What does that atom have inside it? So how does this work? How does this electron work? Okay, I'll just share the atoms models in which we are going to study each and everything over there. So you can see that I'm going to show you 4 models in which we are going to observe the similarities over there. You can see that every atom, every model has some similarities. What are those similarities? All the atoms has proton and electron inside them. Okay, positively charged particles we call them as protons, and negatively charged particles we call them as electrons. As you can see, the positive sign indicates the protons in the first image. In the second image, you are going to see that blue particles and red particles, they are protons and neutrons combined together. Okay, the blue color indicates the neutrons and the red color indicates what we call protons inside it. Similarly, the yellow colored, okay, you can say that they are electrons which are revolving in the orbit around them. Similarly, a charge cloud model also has the same thing. Number of protons and number of neutrons are attached together in between, and electrons are revolving around them, okay, attracted towards them. In the Rutherford model also, we can see that positivity particles are at the center and electrons are revolving around it. From this we can say that okay, an atom, it is a fundamental unit of matter made up of positively charged particles called protons, neutrally charged particles called neutrons, and electrically negative charged particles, they are called as electrons. Right children? So we came to know that the negatively charged particles, we call them as electrons. We are making these electrons to flow. Second, again the question remains same, what is this electricity? So everything is made up of a matter of atoms which consist of positively charged particles, protons, and negatively charged particles, electrons. As you can see a model over there, which we are assuming that right model right now. So where we are going to see protons and neutrons are bonded together at the center, and the electrons will be revolving around them. So we are going to see that the number of protons will be always equal to the number of electrons in an atom. Always to be a stable atom, we are going to see the number of protons will be number of electrons. See, an atom will usually have the same number of positive and negative charges. Means if there are 10 electrons, the same number of protons will also be there inside it. Okay, why? To get binded, to be stable. Okay, to be stable, neutral, you can say. To be a neutral atom, they need to be what you call equal. If they are not equal, they will be unstable. Okay, they will either lose the electron or they will gain the electron. Okay, so now what is this electrical charge? Electrical charge is given by, so these positively charged particles are nothing but the electrical charge. Okay, negatively charged particle, electrical charge, and they are given by the symbol Q. So electrical symbols are given what you call, we are going to represent it by Q. And the electrons are the charge carriers that flow in the electrical circuit. Now usually in our circuits, electrons are the charge carriers. They will be flowing in our circuits from negative to positive terminals. Now as we said, we are going to make electrons to flow. That's why we are going to say that electrons are charge carriers in our circuits. They are represented by Q and they are measured in coulombs, and the SI unit of the electrical charge is given by coulomb. It is represented by the symbol C, capital C, you can say. Okay, so you have to remember electrical charge is represented by Q and measured in coulombs, and the SI unit, it is the symbol, it is given by C. You are going to remember it, children. Okay, so the charge on a proton, so one proton, it is equal to how many charges? So we are going to see that it is equal to 1.6 into 10 raised to minus 19 coulombs of charges. So it is equal to 1.6 into 10 raised to minus 19 coulomb of charges will be there inside it. So that many charges will have one proton itself, means positive charges. So that many positive charges will be there in a proton. Similarly, an electron will also have the same number of charges, 1.6 into 10 raised to minus 19 coulomb of charges, right? So these are all the values which you are going to remember while solving the problem. It might be helpful. Okay, so let us again conclude. What is this electricity again? Electrons have a negative charge measured in coulombs. Now electrons move around a circuit to form negative to positive, from say negative to positive. Like, why negative to positive? So they, unlike poles, will attract. So positive to positive they will not move, so always they will move from positive to negative, and it is give to the rise to electric current. When these electrons move, that will be a electric current. Okay, so next we also know that the like charges will always repel each other. As you can see in this vertical image, they always, that like charges are fighting. See, minus minus and plus plus charges, they do not like each other, means they will repel each other. Oppositely charged particles, plus and minus, they are going to attract. That's why these electrons move from positive to negative. This makes the electrons to move, or you can say this makes the electrons to flow through this circuit. Okay, now the question arises, what are these conductors? Can you name some conductors and insulators? What makes them conductors or insulators? What are these insulators? So these questions you might have. So you might have learned what are these conductor means. Conductor means anything which allows the current to flow through it, right? You might have studied this one. Okay, but now you are going to study how they are going to conduct that electricity, how they are able to conduct electricity, how they are allowing the current to flow through them, right? We are going to study what are these insulators. Insulators are nothing but anything which do not allow the current to flow through them. And what makes them not to flow the electrons through them? Why they are not able to flow the electrons through them? Because every matter is made up of protons and electrons. If every atom, it is from there we are making the electrons to flow through them. Why these insulators are not making them to flow? We are going to study in the next bit. Let us go for the next bit, that is, what are conductors and insulators? What makes them good conductors? So good conductors allow electrons to move through them easily. Insulators do not allow the electrons to move through them. Now we have studied this one earlier. Now let us go for the atomic model. Okay, what is the model of metals over there, and what is the structure of an atom in non-metals? As you can see, I will zoom it little bit. Okay, I will compare the metals and non-metals atoms over there. Okay, now as you can see, metals and non-metals atoms we are going to see. What are the difference between both them? So as you can see, the metals, they are having large number of orbits inside it, and many electrons are there, right? If orbits are more, electrons will also be more, right? Here in non-metals we are having very least number of what you call orbits, and they are very near to the what you call protons, or you can say nucleus. As you can see here in metals, the electrons in the outermost orbit are little bit far. To make you understand, I'll give one simple explanation, or you can say a simple what you call example. Suppose there are two brothers. Okay, suppose there are two brothers. They are staying in the same city till 10th standard. Suppose. So after 10th, what will the parents do? They will send one of their child to a farther place like Bangalore or Delhi, and one more child they will make them to stay along with them. Okay. So next, the possibilities of getting spoilt. So a person, the one who is staying away from the house, and no one is look after them, and one more person who is there always in presence of their parents. Now who will get, what are the chances of the persons to get bad habits, children? The one who is staying very far away from the house, or the one who is staying at the home will get that bad habits? So question is, the one, whether the person who is staying away from the house, Bangalore or Delhi, whether he will get the bad habits, or the one who is staying very near to the parents? Now obviously your answer might be the one who is staying away from the house, because there is no one to look after him, there is no one to take actions on him, right? So he may get a bad habit. I will not say that he'll definitely get it, but he may get spoiled. But the one who is staying at the home, so he will not get that bad habits. Why? Because parents are looking after that fellow, right? So the parents will keep an eye on him. So what will they do? So they keep on observing what is that fellow doing, whether he is smoking or not. So if he is smoking, they will take off their shoes and properly give him a proper treatment, right? Similarly, in metals also you can see the outermost orbit electrons are very far away from the protons, because they are having maximum number of orbits. So now these maximum number of orbits make them, so their force of attraction will be less here as compared to here. Just observe, see, here there are only two orbits. They are very near to their protons. See, here the force of attraction between the protons and electrons will be more. So whereas here it will be more to the nearest electrons. The force of attraction will be more to the nearest electron. The chances of this electron which are in the outermost orbit, they may come out of the orbit. Why? Because the force of attraction might be very low as compared to the non-metals. Here we are going to get one extra electron which may come out of that orbit, that is called as free electron. We are going to get free electrons in the metal, whereas as there is more force of attraction between the atoms, electrons and protons, we are not going to get any extra electron, and here we are going to get an extra electron. That extra electron we are making it to flow. That's why metals will conduct electricity. Why? Because we are getting an extra electron over there for which we can make it to flow. Whereas non-metals, we are not going to get any extra electron. Okay, you have to remember, children. That's why they will not conduct electricity. Whereas metals, they are going to conduct the electricity. Okay, so this is how these metals are conductors and non-metals are insulators. They will not conduct the electricity. Okay, this is all about metals and non-metals. Why these metals are. So now what is this electricity again? The movement of charges in a circuit, we call this as electric current. So electricity is the movement of charges. Whatever the extra electrons we are getting in metals, we are making it to move, right? Electricity, we are going to make it to flow in metals only. Whatever, if we just take a stick and if we allow the current to pass through, will it conduct? No. It will not conduct electricity. Only metals will conduct, and that metals will be having free electrons. Those free electrons, they are making it to move, children. Okay, this is called as electric current. Okay, as you can see, from the electrons are moving from negative to positive, you can see. Okay, but the current flows in opposite direction. Electrons will flow from negative to positive, but the current direction will be opposite, means from positive to negative. So electrical charge, current and time, we are going to study it now. Electrical charge is given by the symbol, see, electrical current is given by the symbol I, not charge. So it is electrical current. What is this current? Flow of charges. It is given by the symbol I, and it is measured. Okay, electrical current is the movement of negative charges in a circuit. Remember this one, children. Electrical current, it is given the movement of negative charges in the current. Now electrical current, the amount of charge flowing per second is given in a given unit. It is called as current also, you can say. Current is the amount of charge flowing per second in a given unit of time. Okay, so that is, you can say, charge is flowing in per second, you can say. That is called a 1 ampere, 1 coulomb of charges. Okay, so now we are having amperes. It is given by the symbol. We are going to measure it in amperes. Okay, amps you can write, or symbolically we can write it as A. Okay, so if the current is charge flowing per second, then okay, we are having a formula. We are having a formula called I, it is equals to Q by T. So 1 ampere is a 1 coulomb of charge transferred in 1 second. Now we can say, see, this one we are going to say that if charge is 1 coulomb and time is 1 second, so we call it as 1 ampere, children. Remember, so 1 coulomb of charge transferred in 1 second, we call it as 1 ampere. Okay, so we call it as 1 ampere. You have to remember this one. So charge, electrical current is given by charge is flowing per unit time, and 1 ampere is given by 1 coulomb of charge transferred in 1 second. Okay, current in amps, time it is given in seconds, and charge it is given in coulombs, children. Okay, so next thing we are going to study is, we are going to rewrite the same formula what we have written it now, that is Q, it is equal to IT, they have given, but we are having a formula I, it is equal to Q by T, right? So this, if you want to find out the Q, we are just multiplying this one, right? If you want to find out the time, just Q by I we are going to do, right? So these are the things which we are going to use it while solving the problems. They may ask you the questions related to the charge, time and the current. They may give you time, they may give you the charge, they will ask you to find out the current. So this is what we are going to use the formula. Okay, so now the device used to measure the current is ammeter. So from which videos we are measuring the current. So this is the image what you are going to see on the screen. It is ammeter from which we are going to measure the current. We are measuring the current with the help of a ammeter, children. So ammeter is always connected in series. Okay, we are going to study about series connection, parallel connection in a upcoming video. Okay, you can see it is connected end to end, means after the it is in series in the connection. Okay, we will study what is series connection, but remember this one, ammeter, it is a device used to measure the current, and it starts the zero from here, not from the middle, and it is used to measure the current. Okay, one more device is there, that is called as galvanometer. Okay, the galvanometer, it also measures the current. It works like a ammeter itself, but the thing is that it can also measure the small amount of current also. If there is a small amount of current also, it will measure. See, just see, it will also show the direction of the current as well. You have to remember this one. So galvanometer, it will not only measure the current, it will also show the direction of the current, and even a small amount of current also it can detect. That is the most important property of this galvanometer. Okay, so this is all about galvanometer and ammeter. Now next thing which comes is potential difference. So before going to the potential difference, I'd like to tell you, thing is that anything, suppose if you are if you want to move, suppose if you are standing at a position, one position, if you want to move, whether you need to pick up your legs and keep it in front so that you can move. You are spending some energy, right? So that energy we need. Similarly, suppose there are, as you can see, there is a tank, water tank here. Okay, so water tank it is there, and tank B is there, and you can see the water level in tank A is more as compared to tank B. Okay, if you just open the wall, this wall, what will happen? The water either it will come from what, tank B to tank A, or it will come from tank A to tank B. Obviously your answer will be, so the water flows from tank A to tank B, right? So why it will move? I'll just tell, because it has higher potential energy here as compared to tank B. It will move until the water inside both the tanks will get stable, right? Similarly here, and we can see a tank which is very high as compared to tank B. So water, whether it will flow with more speed here or here, obviously your answer will be that water in the tank A will move more with a more speed. Why? Because it has higher potential energy, it is at more heights, you can say. Similarly, now current should move, the what you call electrical charges should move. Without any energy, will they move? So there should be a pressure difference, right? So electrons, to move electrons, we need the pressure difference over there between the two terminals. That is called an electric potential. So potential difference, you can see, so whatever we are doing, we are making electrons to move from one point to other point, or one terminal to other terminal. So what we can say, the work done on unit positive charge, suppose whatever here the old when it is going, so what we are doing a work on it to move from one potential to other potential. So you can see here old man, it is coming here, they are getting the energy over there, and now here they have become a young persons here. As you can see, battery, what it is doing, it is giving energy to the electrons to move. Okay, suppose I'll just give an example over there. Suppose if you are sitting on the bench, okay, suppose one person, second person, third person, you are sitting on the bench there. Now I need to make you move. To make you move, what I should do? If you are sitting there only, I cannot move you. So I should ask one person to come out, right? I should ask one person to come out. So that what we are doing, I'll make him to come and I'll just allow him to sit here. So what will happen? The person who is sitting here will go this side, and the person who is sitting at the corner will come at the middle, and this person will occupy this space. What's happening over there? We are just, what we are doing, we are just changing the position now. We are just taking an electron and allowing to go from a other terminal. So battery, what does it do? It creates a potential difference. What is this potential difference? It is work done on unit positive charge. What we are doing? We are doing a work on a unit positive charge to move from one terminal to other terminal, right? Have you played a slide, children? You might have played a slide in your childhood. Okay, when you sit at one position, what will happen? You will come down. Why? Because the potential energy at the height, it is more as compared to less. So you will move from higher potential to lower potential, right? So similarly, what happens when you are sitting on a bench? Will you fall down immediately? No, because at all the point the potential, it is same. So potential energy is same. If you make that bench tilted one, then you will come down, right? Similarly, so if you want to make electrons to flow, we need a potential difference there. So potential difference is nothing but work done on unit positive charge. Means what you are doing, you are taking suppose there is a wire, you are just allowing the electron to flow there. What we are doing on electron? We are just creating a potential difference over there. We are going to give a higher potential at one point, definitely the electrons will move from one point to other point. This is called as potential difference, children. Okay, electrical potential we call it as when a small electric charge is placed in the electrical field due to another charge, it experiences a force. So work has to be done on a positive charge to move it against the force of repulsion. Okay, electrical potential is defined as the work done in moving a unit positive charge from infinity to that point. From infinity means it may be at any distance. We are making to move from one point to other point. Suppose we are generating the current at a power station, Almaty Dam. So if you want to get the current here, So what we are doing, we are making it to flow. So it is that potential difference is created by the generators, electrical generators. So that potential difference, because of which electrons will flow from one place to another place. This is called as electrical potential. Electrical current, if you want, we need an electrical potential. If you want the electrons to move, then we need an electrical potential. With the help of this electrical potential, we are going to make the charges to flow. Okay, without the help of battery or any source, we cannot move the electrons, right? We cannot move the electrons just by rotating any wire, right? So we need a potential difference there. It is been created by the batteries, you can say, sources, you can say. Usually the device used to maintain the potential difference is what? Battery or cell itself. Okay, the potential difference, the concept of electrical potential is closely linked to the electrical field. Small charged particles within a, so we can say within an electrical field experiences a force. Why it is experiences a force? Because their potential difference will be there. To brought the charges to the point against the force requires work. So we need to do some work on that electron to make it to flow. That's why we need this potential difference. At electrical potential at any point is defined as the, see, this is the most important, the energy. You can say the electrical potential at any point is defined as the energy required to bring a unit test charge from infinite distance to slowly to that point. That's what we have said. So we are bringing a charge from one point. Suppose you are holding a wire at this point, from that point to this point we are bringing it. So to bring that one, we are doing a work over there. So it is usually measured in volts. Remember children, we are going to measure the potential difference in volts, and volt of the potential is for which 1 joule of work must be extended to bring a charge of 1 coulomb from infinity. I'll tell you in detail about this, but remember it is measured in volts. You might have heard the word voltage. You might have heard the word voltage. Voltage is nothing but the potential difference. So potential difference we are going to calculate work done upon quantity of charge moved. Okay, work, we are doing work on what? The charge itself. Work done upon charge will give you voltage. So potential difference we can say. Potential difference is work done on unit positive charge from one point to another point. So work done SI unit is joules, and SI unit of charge it is coulombs, and SI unit of potential difference is volt. 1 volt we can define it as work done, 1 joule of work done divided by 1 coulomb. Means 1 joule of work is done on 1 coulomb of charge to move from one point to another point, that it is called as 1 volt children. 1 volt is defined as 1 joule of work done on 1 coulomb of charge. It is called as 1 volt, remember children. So work done, it is measured in joules. Okay, so we are going to measure in joules, and the SI unit of charge it is coulombs. 1 volt 1 per coulomb of charge we are going to see. Okay, this is all about voltage children. So next, the device which measure the voltage, it is nothing but the voltmeter. The device which measure the potential difference, it is called as voltmeter. We are going to just measure it children. Now you may get a question in the examinations. What is the device which is used to measure the potential difference? Voltmeter. And the device used to create a potential difference is battery, not a voltmeter. Voltmeter we are just using it to measure the current. Okay, and one more thing, voltmeter has higher resistance, so that it takes a negligible current. Okay, so it is having a high resistance children, so it is always corrected in parallelly. Okay, during studying about series and parallel connection, I'll explain it to you. Okay, next thing which comes is electrical current. We have studied it, 1 coulomb of charge per second. Now we are going to study what is circuit diagram children. Circuit diagram, you can say it is a path of a current in which the current flows. It is a closed path of a current in which the current flows. Okay, usually called as. So you can see the diagram over there. So it is a schematic diagram in which different components of the circuit are represented by the symbolic conventionally used. So these symbols which we are using over there, we are denoting these symbols and the electrical components which we are using here with the help of these symbols. Okay, conventional symbol used to represent some of the most commonly used electrical components. See, this symbol is used to measure denote the electrical switch, and this symbol is used to denote the electrical battery, and this symbol it is used to denote the bulb and wires. Okay, let us study step by step all the electrical components which has been given in your textbook. That is, first thing, it is electrical cell. The symbol which we denote here, it is a electrical cell. One bigger stand will be there and one smaller line will be there, and this bigger line indicates the positive terminal and the smaller line will indicate the negative terminal. This will indicate electrical cell. Next is battery or a combination of cells. You can see there are multiple positive and negative terminals. That means that it is a combination of cells. That's why it is called as battery, you can say. The larger side will larger line will indicate positive terminal and the smaller line will indicate negative terminal. The plug key or a switch which is open. Now open means it is off. Okay, this you can see here there is nothing in between, just two brackets and it is been connected to the lines, and here nothing is there inside. Whereas switch key, plug key or a switch which is closed, or you can say on, switch on, it is like this. So wire joints are there, it will be like this, one straight line and which is the T-like structure and one dot over there. Wire crossing, you are just taking a wire and just crossing, making a hump over it. Okay, these are wire crossing without joints, you can say. Next is electrical bulb. In short, you can draw like this. Okay, it is looking like M, and you can say this one also you can draw the complete bulb also, but it takes time. It will be easy to draw it fast. Okay, next important component is resistance. Okay, resistance, it is given by this one, this symbol. There is a zigzag path. Okay, and variable resistance, we are just adding a arrow mark to the resistance. Okay, you can see, you can draw it like this, or in this way you can draw. Okay, then one more, it is ammeter. You are going to see a symbol, it has been written, plus and minus symbol is also given. Voltmeter, same, just we are just placing a letter V inside it, voltmeter. And one more source, you can say, I'll just show you. One more you are going to draw like this, and just you are going to indicate, that is called galvanometer. Okay, so for galvanometer just you are using a arrow mark over there, children. Okay, children.